many of you know, I have a policy where I forget Turkish the second I walk into classrooms. And I just happen to have forgotten Turkish now as well. So. As Selim Bey said, today's subject is printed circuit board design. There's a perception in a lot of places that making your own PC cards beyond basic cards is incredibly difficult or requires an incredible amount of expertise, and this is just not the case. DIY means do it yourself. Do it yourself PC board design. And it's possible. It's done by a lot of people. I've done it for years. I did it for years in my previous life. I continue to do it occasionally. So my objective today is to share with you some of the things I've learned, because if somebody had sat down with me and gave me a little bit of an introduction, I would have made a lot more progress a lot faster than I did. So I guess the first question is, who is this for? Then, very briefly, we'll talk about why we might be interested in doing this. And finally, we'll talk about when you would not want to do it yourself. I'm assuming everybody here has a basic knowledge of electronics, that you know the basics of electronic parts, you know the difference between a resistor and a capacitor, you know the basics of integrated circuits, what they look like, how they're packaged. And I'm going to assume that you know how to read and use schematic diagrams. And I'm also going to assume that you have an interest in building things that actually work. And by things, I mean electronic things. Why would you care? Well, turns out if you're prototyping a design, if you've come up with a design and you want to prototype it to verify that your design actually works as intended. I had a client whose workflow included, after design, you would have to do a hand prototype, where you would take a piece of perforated board or something else, lay out things as they might be on a PC board, and point-to-point wire everything to verify that the layout and the design worked. I sat down, and on the back of an envelope, I estimated the time involved in prototyping the circuit using hand methods, wire wrapping, or anything else, versus actually doing the layout directly on a PC design program and sending them off for a small production run. Turned out to cost an order of magnitude less in terms of engineering and other resources by going directly to prototyping in PC board. So prototyping in PC board can actually save you money. Another issue, performance. When you're doing prototyping on wire wrapping in particular, you can get a lot of crosstalk between conductors. You don't get very good shielding that you can get very, very easily with a PC board and some other things. So your performance can increase. The other thing about doing manual prototyping or wire-based, wire wrap, perf board-based prototyping is that you can run into issues with reliability and robustness. A lot of handmade prototypes are just not that durable. If you're planning an actual product with small or medium production runs, and by this I mean something in the hundreds, the cost saving of doing it yourself, again, makes perfect sense versus hiring out the work. For small runs, the kind of cost-saving advantages that a professional will bring you are going to be pretty much swamped by the costs of actual production that you're going to have when you're dealing with small and medium runs. There's also this growing area of what's called physical computing and interaction design. There are people who are working in interaction design who are increasingly working with making interactive computing devices. And here I'm thinking about projects like the Arduino, NetDuino, and other things. People involved in this area of design are in constant need of making custom extensions to the circuits that already exist, to things that already exist. So there's a lot of interest on the part of interaction designers and physical computing people in actually being able to design their own circuits. So there are some cases where you should definitely, however, consult with a professional. If you're working with high power, high voltage, or if you need very, very high speed. Professionals have the knowledge and the tools to do the appropriate kinds of, make the appropriate kinds of decisions, and if required, modeling to ensure that you're not going to have issues. If you need very, very high reliability, medical, military, industrial level reliability, you may choose to go with a professional. If you're using latest cutting-edge technologies, flexible boards, micro-miniaturization, and some other technologies, you may want to consider consulting with a professional, or be prepared to do a lot of research on your own. Today we're covering basic kinds of designs. So my plan in the remaining, oh boy, half hour, we are going to get to know some, on a conceptual level, we're going to get to know PC board designs, and we're going to familiarize ourselves with the PC board design workflow. We're probably not going to have time to talk about assembly. After that, we'll take a break for 10 minutes, and then next hour, I'll actually go through a demonstration of the entire workflow using a piece of freely downloadable open source software called KiCad, which is actually something of professional quality that's available to everybody for no cost if you choose to experiment.